Alright guys, this is a problem on circular motion. So these are all going to look, at least for this type, you got an object going around in a circle. I'm going to put it up here. That's its path. It's going to be attached. Let's just say it's attached by a string, and you're rotating it along this direction. So it's going in a circle like this. There's a couple things we can find. We can find out how fast it's going. And then specifically, right now, we're going to focus on the tangential speed. That's this sideways speed. So tangent to the circle. So there's Vt. We can also find the centripetal force. And then that would be, and like from the notes, it's always directed in towards the center. So there's Fc. It's the centripetal force. So there's the two things we can be looking for. Let's start with V. Most likely they're going to give you some more information. Basically, one would be the radius. Let's just say it's 2 meters, just to make it easy. And then they would give you some kind of time, but they're going to give it to you in a weird, not weird way, but you're going to be rotating. And let's just say you take 10 seconds for, let's say, 2 rotations. Hopefully I can fit that in. 2 rotations. For circles, it's periodic. So all we care about is the time of 1 rotation. So when we're doing, let's just say we want to go calculate the tangential velocity, we're going to do 2 pi r over t. That is an r. I just make bad r's, but 2 pi r over t. So we can do, so there's your equation. We want to know the tangential velocity, so we're going to just write, that's the relationship, 2 times pi. The radius they gave us was 2. And then the period, we got to stop for a second. The total time, it made 2 rotations in 10 seconds. The period, this is the time of 1 rotation. So t, just like it was with pendulums, just like it was with springs. T is the period. So time of 1 rotation. All right, so that's a little side thought, but that's what t. So the time they gave us was for 2 rotations. So all we have to do is 10 divided by 2, and then that's our period. So this one, I'll do a quick calculator just so we can check numbers. But you would do 2 times pi times 2 divided by 5. So about 2.5 meters per second is how that would come out. And again, that's your, if you were to let go right at that point, you'd go off to the left at 2.5 meters per second. Now, how much force are you feeling? Here, let's switch up colors. So for FC, we're really going to look at the sum of all the forces that give us Fc equals mc. So it's the same force equation, force equals mass times acceleration, but specifically it's for circle, it's for centripetal motion, so we subscript it with some c's. For this one, we are looking for the total centripetal force. We want Fc, so we don't have to break Fc. I'm going to show you another one where we have to break Fc down into its the forces that are actually causing the centripetal motion. So in this case, it would be T. Well, here, we can do it. What's causing the centripetal force in this case is tension in that cable. So we're looking, in this case, we're going to look for T. The mass is the mass of the object rotating. And I left that off. We will come back to that in a second. We can just make that up. And then AC is its own. Before, when we were looking for acceleration, when we did forces, where there were 3 options, right? All those VF, VI, AT, and D, those equations. For circular motion, centripetal motion, or centripetal acceleration, all we have is V squared over R. So that is how you get AC. So let's just say the mass, let's just say 10 kilograms. Well, why would you be spinning something? Well, let's just say 10 kilograms. That's what popped in my head. Mass is 10 kilograms. We're just going to say that's what it is. They'd have to give us that. V is what we found up above, which is 2.5 right? V was 2.5 meters per second. I am breaking my rule with putting my variables on the right there. Sorry, guys. It was kind of an afterthought, though, wasn't it? 2.5, and then the radius we already established from above. Again, some of this is redundant, so you don't have to write it again. R is 2 meters. So for this one, oh, and almost, some of you probably saw it. I almost left off the squared. It's V squared, so it's 2.5 squared divided by the radius times 10. So, real quick. So 2.5 squared divided by 2 times 10. There's your force. That's your force in newtons, which, whatever, doesn't really mean anything to anybody. But if you multiply by 0.225, it's about 7 pounds, approximately 7 pounds. About 7 pounds. Now, 10 kilograms is 20 pounds. So, anyway, to spin this silly thing, you're putting, and I didn't really specify, so horizontal, that it's a horizontal plane. You're spinning this thing with a horizontal plane, and that thing's putting about 7 pounds of force, of tension in that cable. All right, guys.